This is going to be out of 29, so go ahead and put out of 29 at the top of your paper. Okay? Make sure you're writing all over this thing. This is now your study guide. Okay, so grade it accurately and honestly, but more importantly, get down all the information because you know the summative is going to be just like this. Okay, number 1. Notice the learning targets are already on there for you. Roberto has been playing piano 8 times as many years as his brother Felix has. So whenever you see 8 times, what operation are we talking about? We're talking about multiplication, right? Because if he's playing that many times, if his brother's been playing 1 year, he's been playing 8 years. If his brother's been playing 2 years, then he's been playing 16 years. Okay? 8 times as many. The difficult part, I think, for some people is being able to turn this into an algebraic expression, which is what you are asked to do. And basically, if he's playing 8 times as long as his brother F, then we need to show multiplication of 8 times F. What's the only way that I'm going to accept showing multiplication of 8 times F? Amani. 8F. So, will I accept F8? No. If you did it, make yourself a note. The number always comes first. Will I accept F.8? No. Will I accept 8.F? No. Or FX8? No. Or 8XF? No. Any of those. None of those would be accepted. We write it with the number as a coefficient in front of the variable, touching the variable. Okay? So that's learning target 8. Make sure you give yourself a check or an X for that learning target. Now, if Felix has been playing for 2 years, then we want to know how many years Roberto's been playing. Well, now what you got to do is you're just basically taking that and you're plugging it into where F is. Okay? So if it's 8F, it would be 8 times 2, which would mean that he's been playing for 16 years. 16 years. You didn't finish it? What? Number 3. Now, here's the deal with number 3. Everybody pay close attention. And again, if you didn't have what I'm about to show you, it's wrong. I'm counting work just as much as I'm counting the answer. You've known this about me since August. Okay? You have to prove it to me. It says it right there. Justify your answer. That's just a fancy way of saying prove it. Show me how you knew. Because if you just go through and circle yes, no, yes, no, yes, no, I'm not going to accept it. Because that you're showing me no ability, you're guessing. That's just like on multiple choice. I usually make you show work because if you're just guessing and getting answers right, that grade isn't going to really represent what you've learned. Do we understand each other? Yes. Okay. So you had to show work. When I look at these two expressions, what's the first thing that I notice? What's the first thing that should jump out at you about this expression right here? Is it in simplest form? No. You guys here, do I have sharks?
Yes.
Do I have any more sharks that I can combine it with?
Yes.
Remember, if they're like terms, which a like term is when a term has a variable in it, and that variable is the same variable, you can put them together. Okay? Or constants. They are always like each other, which we'll talk about in a minute. So, if I have 2 sharks and 7 sharks, can I take those and put them together?
Yes.
How many sharks would I have? I would have 9 sharks. What about 3? Is there anything to combine it with? No. Okay? Now, I want to make sure we're clear on something because I see people doing this. What I'm about to write is incorrect, so you can write it if you want. You want to write wrong or something like that, just so you know, I still see some people taking 9s plus 3 and then saying, oh, that means I have 12 sharks. Is that correct? No. What if this was 3 sharks here, then would that be correct? Hello?
Yes.
Yes. But it's not. You can't combine. That's the same as saying if I have 9, let's say I have 9 times 2. Let's say S is 2 plus 3. Can I all of a sudden just go ahead and add 9 and 3 first and say, yep, I got 12 times 2. Can I do that? No, you just broke the order of operations. Cannot do that. Okay? Head up. Okay? By the way, could this also be written as 3 plus 9s? Not a bad idea to write that, just so you know. Okay? Now, what is that called? What is that called that allows me to do that? That's called the commutative property. specifically of addition in this case. Commutative. I didn't spell it right. Let me rewrite that. Commutative, like that. It's the commutative property of addition. There's also a commutative property of multiplication. Same thing, just one's multiply, one's add. Okay? Now, which one do I prefer, though? Which one are you going to need to use in next year's math? In 8th grade, 9th grade, and 10th grade? Which one's the better one? Yep. Yeah, the term with the variable should always be listed first, and you'll learn more about that in the future. But that doesn't matter for us. I mean, I'm content with you putting either one. Okay? So let's go over to the next expression. So here, we got to do the same thing. By the way, this is the work that I require. You had to show me this. If you didn't show me this, it's wrong, and you better be showing it now. Okay, here I have 4 sharks. Here I have 5 sharks. Right? Can I put those sharks together? Sure I can. I now have 9 sharks. So far, is it the same?
Yes.
But it has to be all the same. The difference here is, I have 2 constants, correct? 2 numeric terms. Can I put those together?
Yes.
Sure. Constants are always like each other. So when I take 2 constants and 1 constant and put them together, what do I get? 3. So could I also write that like that? So are they equivalent, guys? Yes, they are. But you must have that work. And if we get to the summative and you're not showing that work, it will be incorrect. Why did you combine that? I don't know, you have to wait till the end. I'll look at it again. Okay, number 4, same way. You must show the work. Once again, same thing. Here I have 5 sharks. Here I have just 1 shark, correct? Here I have 6 sharks. Can I put all those sharks together? Hello? Yes. Here I have the constant 3 and the constant 3. Can I put those together?
Yes.
So I have 5 sharks and 1 shark. That makes 6 sharks. And then I add it to another 6 sharks. What do I have? 12 sharks. My constants, 3 and 3, is going to make what? Okay. Could that also be written as 6 plus 12s? Very good. Doesn't matter. Over here, I have 10 sharks. I have 2 sharks. Can I put those together? That would give me 10 or 12 sharks. Now the 6, is there anything that's going to be able to be combined with that? No, it's not. So once again, it could be written like this, but that answer once again is yes. Those are absolutely the same expression, just written a little bit differently, but it's the same thing once you simplify it. Everybody got that? This right here, guys, is the requirement. You had to show this. You had to show it becoming that. Okay? Number 5. Now I'm going to be real picky about the work that I want here. What did I tell you the first thing you have to do when you do these? Who remembers the first thing? Yeah. Yeah, you have to put parentheses around any numerator or denominator that has an expression in it. For instance, do I need to put parentheses around that? No, that's not an expression. An expression has operations and numbers or variables. Okay? So here, I must put parentheses here. And that just reminds me that I got to get the numerator to one number before I do anything else, before I actually divide by 9. So, if you didn't have what I'm about to write, it is wrong. It's wrong right now. Okay? What is the first step after you put those parentheses on there? What is truly the first step to evaluating an algebraic expression? Yes? You have to take that algebraic expression and you got to turn it into a numeric expression. So, what does that look like? Just like this. You must have exactly what I'm about to write. If you don't, if you're one of these people that's just putting the 6 over the x, it's wrong. This is what I wanted. This is what I've been telling you. This is how I taught you to do it. This is how I want it done. 4 times 6 plus 3. All of that divided by 3. Okay? Everybody got that? If you did not show that line right now, you better be writing it, first of all. That's what I want. That's what it has to be. If you don't have it, it's wrong. Artie.
I didn't put parentheses up in this one.
I mean, that's how I tell you to do it, so yeah. That's what I always said. I always said you put them in parentheses first. Okay? So, Now we should write PEMDAS. You didn't have to, but you should have. I mean, it should be something you've probably ought to do if you need it. We've got to take care of parentheses first, so that's what I'm going to do. So I'm going to do these first ones on the left. 15 minus 6 is going to give me 9. I bring down everything else. Remember, everybody in this room is capable of understanding what one step at a time means. Every single person in this room. Now I'm going to go do the next parentheses. 4 times 6 is going to give me 24. Bring down 9 divided by 9. I did one step. Now 24 plus 3, that's going to give me 27. And then 9 over 9. There we go. Now I'm finally done with the parentheses step. Now I'm on to exponents. Now I'm going to go on to multiply or divide. All fractions are what? So that's going to be here. 9 divided by 9 is going to give me 1 plus 27 over 3. Then I'm going to do this division. 27 over 3 would be 9. 1 plus 9 is 10. So if we're counting lines, you can see how many lines mine was. Yours better look like that. And if it doesn't, it's wrong. I've made myself very clear on how many steps I require and how I want things done. And really, it's not to be annoying. It's to protect you from you guys. If there are some teachers out there that probably don't make their students show this work, so they got students that are just like, okay, I'm going to put 6 there. 15 minus 6 is 9. 9 divided by 9 is 1. 4 times. But I'm telling you, you'll make mistakes if you try to do it that way. So I'm basically trying to help you guys not miss them by making you show all those steps.
I did this first and then I did this. So I first did this and you wrote
That's fine. Okay, number 6. Okay, here we go. PEMDAS question here. Okay, so we go inside parentheses here. Now, what do we always have to deal with when we go inside parentheses, guys? A little what? Mini PEMDAS, right? Because every time, it doesn't matter whether it's inside parentheses or outside parentheses, we still have to follow the order of operations. So we go inside these parentheses right here. Are you going to add or do exponents first? Obviously exponents, right? That's going to be 49, not 14 like some of you were putting. So if you put 14 there, make yourself a note. You should be writing this off to the side saying, okay, I need to make sure that I know that a number squared is it times itself. So 7 times 7. So 4, bring down the parentheses. Remember, we don't get rid of the parentheses until we've gotten it down to one number. Now I'm going to finish the parentheses. That's going to be 52. Now I can get rid of the parentheses by just putting a multiplication sign in there. Okay, now I'm done with parentheses. I'm done with exponents. Now I'm going to go on to multiply or divide, which there's only multiplication. That's going to be 208. And then 208 plus 3 would be 211. Okay, so you must have had all of those steps. Okay? Okay, so the other way that people were doing it, by the way, is on this line right here. I'm not saying you had to do it this way or anything like that, but I did have a couple people that actually distributed here. Okay? So they actually got 12 plus 40, I think that's 196, and then plus 3 like that. Then you get 208 plus 3 equals 211. Either way is fine there. But I think this is the way you guys know more. But you could distribute there. You have to wait to the end. Oh, okay, number 7. Okay, now we should probably write PEMDAS here. Okay, so here's the brackets, the first brackets I see, right guys? Those are just fancy parentheses, right? Okay, when I go inside parentheses like I'm seeing there, then I got to follow a little mini PEMDAS, right? So when I go inside those brackets, those fancy parentheses, I look for more parentheses. So I go inside of there and I see, oh, there's more parentheses. So that's going to be 10. Now I'm going to bring down 10 minus 10. Do I leave the brackets on there? Yes, you have to. Then I bring down 2. Now I'm going to finish the brackets. That's going to be 0. What does it mean when a number is touching a parenthesis or a bracket? 2 times 0 would be 0. So that's the work I would require there. Okay? All right. Here we go. Learning target 1 on these next ones. 8 fewer than x. Another way that this could be, you could see it, you might want to write this. You might see 8 less than x. 8 less than x. Same thing. Think about it like this. If it's 8 degrees fewer than x degrees, and say this was 90 degrees, what is 8 fewer than 90?
82.
82, right? And how would you find that? You would find that by doing 90 minus 8. Well, that's the one little trick here. A lot of people want to do 8 minus x. That is wrong. Because this is the whole. You're saying it's this less than the whole, so it's going to be x minus 8. Okay? Good? Okay, number 9. 10 less. So right when I see 10 less than, you should already be knowing, okay, this must be subtraction. Whether it's going to be minus 10 or 10 minus something, we'll figure that out later. Now, it does say the quotient of p and 2. We know that would be written as p divided by 2. Right, guys? Well, if it's 10 less than that, just like up here, this was 8 fewer or 8 less than that, then this is going to be p divided by 2 minus 10. Things I won't accept, if you want to write these, you can. Like the wrong, so you don't make this mistake. I will not accept p divided by 2 minus 10. By the way, you could have written it like this too. That's fine. I will not accept the divide by sign. Okay, I want you to get in the habit of always writing them in fraction form. Okay, I will not accept 2 over p minus 10. That's the quotient of 2 and p. All those would be wrong answers. Put what you got out of 9 at the bottom, please. Okay, number 10, 8 more than the product. Now, when you see 8 more than, what are we talking about here? Addition. So we're adding 8. Okay, the product of 12 and d. How would I write the product? Product is multiplication. How do I show the multiplication of a number and a variable? Yeah.
There's a number touching the variable.
So we would write 12d plus 8. Is that the only answer I'll accept, Tyler? Is that the only answer that I will accept? No. I will accept 8 plus 12d as well. Once again, because of the commutative property of addition. Okay? It's just I want you guys to get in the habit of writing it with the variable term first. Okay? Number 11. Now, I want to explain this to everybody, so please listen. For you guys grading, this will be kind of tricky. There are 2 learning targets. Okay, now the question itself is only worth 1 point. You either got it right or you got it wrong. Okay? But if you're doing checks and X's, if you miss the problem, you might have an X on one of the things and then a check on the other. Okay, learning target 5 is simplifying. Okay? That's what learning target 5 is. That's truly what we're doing on this problem, where we are simplifying. So if you do the simplifying right, if you get the answer right, you'll get learning target 5 right. Learning target 6, that is the expanding or distributing. Everybody got that? So if you go through here and say you missed the problem, like let's say you did this. Let's just go through it. I'll show you what I mean. Let's say you got 18m. Don't write this because it's wrong. And then you put plus 4. Does everybody see my mistake?
No.
You don't see my mistake?
Oh, you never did that.
I didn't distribute to both terms. So let's say you did that and you ended up, obviously you're going to miss the problem because of it. Well, you shouldn't necessarily, you can, if you simplified it correctly, you can give yourself a check on learning target number 5. Okay? But you're going to give yourself an X on learning target 6 because you messed up the expanding part. Everybody understand that? Okay. All right. So you must distribute first always. That's you got to distribute or expand. Same word, right? Distribute and expand. Let's write that real quick. Distribute equals expand. They're the same word. They are synonyms of one another. They can be used interchangeably. Okay? So when we've got to expand it, that means that we are going to distribute those numbers on the outside of the parentheses through. So remember, you must do it to both terms. So 3 times 6 monkeys would give us 18 monkeys, right? 3 times 4 constants would give us 12 constants. 2 times 1 monkey would be 2 monkeys. And then 2 times 5 constants would be 10. Now we're just combining like terms. So I have 18 monkeys. I have 2 monkeys. Are those like terms, guys? I have the constant 12 and the constant 10. Are those like terms? Okay. So if I combine my monkeys, how many do I have? I have 20 monkeys. And then if I combine my constants, what do I have?
22.
There we go. Would I also accept 22 plus 20m?
Yes.
Sure. Absolutely I would. I would just prefer, that's why the clickers were not, they were kind of misleading a little bit. Like the grades in the clickers were worse than what you guys really did because I can only put one answer choice in the clickers. So if you had this, you would have gotten it wrong in the clickers. This is the one that I put in the clicker because that's the way I want you to always do it. All right, now, factor the expression. Now I am going to be picky on this one once again. Okay, this is learning target 6 also. Okay? Expanding and factoring is all learning target number 6. Now, what number did we always use right here? The GCF. So if you don't have the GCF, you better write this right now. I'd write this on number 12 right now. Just so that you have it. Because, no, it doesn't say it in the instructions, and I really don't want to hear you really any complaining because this is the way I taught you. I taught you to use the greatest common factor. That's the way I've taught you to do it. That's the one you got to use. Some of you can mentally figure out the greatest common factor of those two numbers. If you can't do it, which some of you can't, and that's okay for right now, go over to the side, find the GCF. I know for sure that every single one of you knows how to find GCF and LCM right now, right?
Yes.
We've done it a billion times this year on review sheets and just it keeps coming up, right? So you need to do it. If you have to do this, that's fine. It takes a little bit of time, but it's worth it. So what is the GCF of those two terms? It is 20. Now, what would I multiply 20 by that would get me back to 20R? I would multiply by R. And then what would I multiply 20 by that would get me back to 40? 2. And that's your answer. That's all I'm accepting. You put 1R? I'll accept it. I shouldn't, but I will. It's not as important this year as it will be next year. I can tell you your 7th and 8th grade teachers, if you try to put a 1 in front of a variable, they will probably mark it wrong. So just keep that in mind. Okay, it's just not proper. You just don't do it. It's not proper notation. Yes? No, that's not the GCF. I know some of you are saying, well, why can't I use 5? And, you know, technically, yeah, it's equivalent. I'm not saying it's not. But the way I've taught you is I've always taught you to use the GCF. That's the way we've always required it. That shouldn't be any surprise. It has to be the GCF. So if you're somebody that missed it because you didn't use the GCF, make sure you're writing this and making yourself a note to use the GCF. Number 13, you're just expanding. What's another word for expand, guys? Distribute. Same word. Okay, so I'm going to distribute to both terms, of course, which means multiply. 3 times 6 horses would be 18 horses. 3 times 7 constants would be 21. Okay, number 14, same rules apply. Learning target number 6, that's the expand part. Learning target number 5, that's the simplify part. So we're going to expand first. That's going to be 14n plus 16 plus 5n plus 5. Okay, I have 14n there. Oh boy. 14n. Has it got anything like it?
Yes.
5m would be just like it because it has the same variable. And then we have the constant 16 and 5. Those are obviously like because constants are always like. We're going to put the n's together. I'm going to have 19n plus 21. 21. Yeah.
I got everything right except back.
By the way, just to make sure I'm clearing this up, would I also accept 21 plus 19n?
Yep.
Sure, because of the commutative property. Now, if it's subtraction, that changes the whole game. That's a little different, okay? Let's go on. Number 15. Here I have some zebras, right? I have 8 zebras. I have 12 zebras. I have 4 zebras. Can I take all those zebras and put them together in one group together?
Yes.
Sure. Here I have the constant 9 and the constant 6. Constants are always like. So we're going to put the zebras together. 8 and 12 makes 20. 20 and 4 makes 24 zebras plus 15. Plus 15. And if you're missing these because you're just making adding errors, like that's what happened in my other class, there was like just a lot of adding errors, like thinking that this was like 22z. Like, guys, come on. I mean, you have a calculator sitting there. I mean, you guys should be able to do basic addition and subtraction. I get that. But if you guys are finishing your test with 25 minutes to go, why not go back and check things like that? Because technically, if you're just adding wrong, but yeah, you know what you're doing, you're missing points for something that has nothing to do with the skill we're trying to learn. You understand that? Okay. Number 16. Do you think I'm going to be picky about this? Yes, I am. What is the first step to evaluating every algebraic expression? You may want to write that. You may want to write steps to evaluate. You may want to write it. And what is step number 1? The very, very most important step, yes? Turn into a numeric. Turn into numeric expression. So another way to say it, basically plug in the whatever the variable equals, plug it in, but you do no math. No math is being done. Number touching a variable obviously means multiply, so we're going to have 2 times 4 plus 10 plus 4 plus 6. That's, if you don't have that line exactly like that, it is wrong. You do not get the point. I've told you from the beginning, I want it done that way. Once again, just to protect you guys from getting it wrong. Okay? If you wrote PEMDAS, which, as I've said 100 times, it's encouraged. There are no parentheses. There are no exponents. There is only multiplication. It's going to be 8 plus 10 plus 4 plus 6. Now I'm done with that. Now I'm on to addition. Which addition am I going to do first? I'm going to do left to right. 8 plus 10 is 18 plus 4 plus 6. Now I'm going to do 18 plus 4. That is 22 plus 6 is?
28.
Is that the right answer?
Yes.
28. And then I guess if you wrote these steps, I kind of quit doing this. Turn into a numeric and then do 1 step rewrite. That's the way I wanted you to do it. You guys are all capable of following those basic 2 steps. You're old enough. You can do it. It's just about doing it. Plain and simple. Okay? Let's go up to number 17. Same way on this one. Follow those 2 steps. The first step would be to turn that algebraic expression into a numeric expression. So that's going to be 2 times 9 plus 7. Okay? Following PEMDAS, I'm going to do multiplication first. 18 plus 7 would give me 25. You must have those steps. If you don't have that written, wrong. What I have exactly has to be there. Okay, number 18. As you guys will remember, I said any time you see an expression in the numerator or denominator, you must put it in parentheses. So here we go. Put this in parentheses. Now we've got to turn that algebraic into a numeric. So here we go. 8 times 5 over 4 plus 5 plus 5 divided by 10 plus 5 over 5. Now I'm going to do the parentheses first. So that's going to be 8 times 5 is 40. Bring down everything. 5 plus 5. All of that divided by 10. Now I'm going to do those next parentheses. 5 plus 5 is 10. Now we got 40 over 4 plus 10 over 10 plus 5 over 5. Now I'm on to exponents. Are there any exponents? Nope. Is there any multiplication or division? Sure, all fractions are division problems, so I'm going to do that. 40 divided by 4 is 10. Plus 1. Now I'm here. It's going to be 11. Plus 1 is 12. So you can see how many lines mine is? That's what the requirement is. Looks like 1, 2, 3, 4, 5, 6, 7 lines, and then the answer would be the 8th line, I guess. Okay? Let's go on to number 19.
Mr. Garrison, what if you did this?
I'll have to look at it at the end. Kyle completed 14 problems for tonight's homework before dinner, and then he completed the other problems after dinner. Write an expression to figure out the total. So right away, you should know if we're trying to figure out the total, then it's either going to be part plus part equals whole, or it's going to be part times part equals whole. Now, are we going to multiply the before problems and the after problems? Would that be right? No. We're going to take what he did before and add it to what he did after. Now, what's the other method? What else would I accept here? P plus 14. Either one there. Go ahead and put what you got out of 10. Okay, number looks like 20. Okay, the triangle has side lengths, and I gave you a triangle. If there wouldn't have been a triangle, I would always expect you to draw the triangle out. So we know it's going to be 7m plus 3, 3m plus 1. You should always write these lengths on there, and then 4m. We know that when we find perimeter, we just add up all the side lengths. So it's going to be 7m plus 3, 7m plus 3, plus 4m plus 3m plus 1. So now we're just simplifying, just like we did on the other one. So I see 7 monkeys, I have 4 monkeys, I have 3 monkeys. I have 3 constants, I have 1 constant. I can combine all these. That's going to be 14 monkeys plus 4. You have to wait. Okay, next one. Next one here. 21. Again, I'm going to be picky. This is what people do. This is exactly why I make you guys show all your work. If you gave this question right here to a lot of people, regular people, adults, high schoolers, I would guarantee that a lot of them would miss it. Here's why. Because everybody wants to say, okay, plug it in. 2 times 4 is 8. 8 to the 3rd power is whatever that is. That is wrong. You just broke the order of operations. This is why I make you turn the algebraic expression into a numeric. So again, you had to do what I'm about to show you. 2 times 4 to the 3rd. Guys, do you multiply or do exponents first? If you didn't do it, it's wrong. That's going to be 64. And then 2 times 64 would give you 128. You must have your work exactly like that, and if you don't, it's wrong. Okay. Next one. Which 2 answers did I get rid of on here? E and F?
Yeah.
Okay. So obviously you have this expression right here. What do you have to do to it, guys? You got to expand it or distribute it. That's the only way. And then you get 8 plus 4m. Well, you know that addition is commutative, so we would accept either one of these, right? So you could have C and D. You must have both of them.
I did expand. Is that okay?
Well, how did you do it then? No, that's wrong then. You got to always prove your answers. That's something I've been harping on all year long. You must prove your answers, and this proves it. Otherwise, like I said, I could just think you're guessing, which I know you're not, but that's the way I've got to do it, okay? All right, next one. Now there's 2 ways you could have done this. Pay attention. The first way is just to simplify. Okay, if I have 12 x's and I'm dividing them by 4 x's, how many x's do I have? When I have 3 x's plus 8, right? And then over here, if I'm combining like terms like we've been doing, I have x and 2x, that makes 3x, right? And then I have 16, but here's the difference. That's minus 8. So what is 16 minus 8, guys?
8.
Plus 8. So the answer is yes. Now, there's another way you could have done it. And I showed you this method, and I will accept this method. That is where you just pick an x value. So how about 1? 1's always an easy one to deal with. So basically, you plug 1 in here. So you would say, okay, what is 12 times 1 over 4 plus 8? And then over here, you would do 1 plus 16 plus 2 times 1 minus 8. And then basically, you would evaluate those with x equaling 1. And if you get the same, if it equals the same, that's the same as showing your work. I'm good with that method as well. Okay? All right, let's go on. Number 24, another simplifying. So we're going to first of all expand. That's going to be 3x plus 6 plus, expand here, it's going to be 2x plus 24. So I have 3x and 2x, those can be put together obviously. And then we have 6 and 24, those can be put together. So I have 5x plus 30. You have to wait to the end. Okay, number 25. Now, this was a very highly missed question in my other class. I saw a lot of people doing this. This is why I always tell you guys to draw a picture. This is exactly why I tell you to draw a picture. I had people just going, oh, okay, so I'm just adding these two. So they ended up getting 2x and 6x makes 8x plus 3. That's wrong, guys. Okay, that's wrong. This is a rectangle. A rectangle has 4 sides. If you drew the picture out, you would have probably realized, oh, well, if that's 2x plus 3, what is this? 2x plus 3. And if this is 6x, then what is this? So you've had to add all those up, okay? Now I'll just do it kind of the cheater method, where you just kind of highlight the like terms going around here like this. Those are like each other, and then those are like, right? I'm going to combine those. So I have 8, 10, 16x plus 6. There's your answer. Okay? Always draw a picture, guys. And if you didn't, I hope you are drawing it right now, because there's going to be one just like it on the summative. Just like the triangle question up in the upper left of the page, I may not give you the picture. Now, triangles are easy because they only have 3 sides, and obviously there has to be 3 lengths. But a rectangle, I only had to give you 2 lengths, but that actually gave you 4 sides. Okay, next one. This number 26 right here is worth 4 points. So that means each one of these is its own point. Everybody got that? Okay, terms. Anything separated by an addition or a subtraction sign. So we got x, we got 6, we got x, we have 3x, and we have 10. Okay, like terms. I know that, first of all, like terms, the first like term I'm going to talk about is any constant is always like, right guys? So I know that those are obviously going to be like, so I'm going to write those first, 6 and 10. And then I know that if they have the same variable, then they have to be like as well. So you must have this exactly.
Do they have to be in order?
X, and 10. Whoops, I wrote 10. Didn't mean that, sorry. X, and 3x. Okay, you could have had the variable terms listed first. That's fine. No, they didn't have to be in any order. You just had to put these grouping symbols around showing those are like terms, those are like terms. Okay? Remember, a coefficient is just the number directly in front of the variable. It's not the variable. It is what's in front. So it's this right here, and this right here. So we should have 1, 1, and 3. Okay? And finally, constants. Those are just your numeric terms. So we know that's going to be 6 and 10. Okay, that back page is out of 10. So as I said, the entire thing is going to be out of 29.